In this video exercise, we will visualize and generate a movie of the trajectories from a Desmond molecular dynamics simulation using the trajectory panel from within Maestro. First, we'll import the trajectory, if it has not already incorporated into the project automatically, by going to Project, Import Structures, then open the -out.cms file. Note that the -out.cms file is in the same location as the trajectory directory, which contains the trajectory frames. Now, over in the entry list or project table, you will notice a T for the imported entry. Clicking this button will open the trajectory panel where you can play through the trajectories, examine individual frames, and export trajectory data in a variety of forms. The toolbar contains a standard set of controls for playing through the trajectory frames, such as the Play Forward button. In the Frame Control section, you can control the selection of frames and the speed of play. Here, you can define the frames at which the play starts and ends. The frame slider can be used to select the frame to view. This shows the current frame number, and here the total number of frames. And here you can set the number of frames to step when playing through frames. This displays the time for the current frame, and here the total time for the trajectory. And the speed slider sets the speed at which the frames are played. Note that the clipping planes are hidden during continuous play. This is just to speed up the play by about 50%. In the display section, you can control how frames are displayed in the workspace and what features are displayed. So here, you can use a lower quality drawing to speed up play, particularly useful if you are representing tubes or spheres. You can update the secondary structure assignment for each frame here, and here you can show and hide the simulation box or coordinate axes. For the replicate system, you can enter the number of replicas of the system in each of 3 directions. This can enable you to visualize any movement across the simulation box boundaries. Here you can smooth the trajectory by averaging the coordinates over the specified number of frames. In the positioning section, you can select an option to control the positioning of each frame relative to the workspace during play. By default, molecules in the workspace are centered. But you may want to superimpose on a particular frame, such as frame 0, so that the structure in each played frame is aligned on frame 0. And here you can pick the atom for frame positioning. In this case, it is superimposing on molecule number 1, which is the protein. Okay, now let's look at an example in more detail. Let's first show the ligand and the binding site residues within 4 angstroms. Now the changes seem to be a bit too dramatic. This is probably because we are stepping through every 52 frames. So let's bring that number all the way down to 1 so we can view every single frame. So that looks slightly better, but perhaps we should perform smoothing by averaging over, say, 2 frames. Okay, now let's show hydrogen bonds and maybe a measurement like a distance. Now notice the waters that were initially around the binding site have drifted away back into the bulk, and presumably new waters have entered the binding site region, but are not displayed because they were not part of the initial 4 angstroms around the ligand. So we'll need to head back to the trajectory player and use the Atoms to Display in Each Frame option. Here we'll select the ligand, but also use the Proximity button to expand the selection to within 4 angstroms, and to fill residues. We'll also make sure that we don't show non-polar hydrogens. Then we can check Display Only Specified Atoms, and then press play. Now only the residues, including waters and ions, that come within 4 angstroms of the ligand will be displayed, otherwise they'll remain hidden. Down here we have 3 output buttons that allow us to export the trajectory as either a structure, an image, or a movie. So for structure, we can export to file or to the project table. We can export the selected frames, which is defined back in the frame control section. We can export only the current frame as a single or multiple entry. If you choose multiple entry, then waters, ions, and the protein in this case will be separate entries. You can also define which atoms to export. So for example, you may want to export only the protein ligand complex. For image, we can save the image. And for movie, we can export a movie in MPEG format for the selected frames or for all frames. Now under the options, we can select a resolution, the quality, and the duration. So here you can limit the movie to a specific duration or record at the default 0.04 seconds per frame, which corresponds to 25 frames per second. Now before recording a movie, you may want to adjust a few settings. So here we'll increase the smoothing even more to average over 10 frames. And in this case, we'll only use the first 500 frames for this example, just to keep the exercise a little shorter. We'll record in the highest resolution and the best quality. Once that's recorded, we can open the MPEG movie and view the animation.